Material balance analysis depends on the law of conservation of mass, and it is used to check that the materials came inside the process are the same or are different, low production, high production. We need to make sure where did our chemicals go. We need to conduct material balance to know. We need to consider cases happening inside an industry that involves and deals with material balance analysis. And this, what we have found or what we have discussed before, steady state, unsteady state, physical non-reactive or chemical reactive. And because you are more likely to encounter or face these situations, maybe together, maybe separate, then let's start from zero step and define everything we need to know when we have material balance problem. Let's even change the size of the video and make it bigger. I like that, no more black screens anymore. I will give you a question and I will discuss every concept related to material balance problem, step by step. Propylene, petrochemical, is a must-have in our lives. It can enter as a raw material and make, through what we call polymerization, the very important product, polypropylene. Polypropylene is famous chemical. It is strong, flexible, resistant. That makes it a promising chemical to be used extensively in packaging like bags and containers. So it's very important to make propylene in order to have what we call polypropylene. And the catalyst is Ziegler-Natta, if you want to look it up. It can be also used as a raw material to make, through oxidization, propylene oxide. And this can be done if you enter air or oxygen inside the oxidization process. Then the produced propylene oxide will enter a hydrolysis process to add water, and then it will form what we call isopropanol, which is the one that we discussed before, used for hand sanitizer sometimes. The catalyst used in this process is sulfur-based. It has to contain Fe that converts the propylene into propylene oxide, and then adding water will produce what we know isopropanol. It can be also used as a raw material to make propylene glycol, and this propylene glycol is used a lot in pharmaceuticals. I think I made my point when I say that propylene is very important chemical and it is a must-have in order to make these very important chemicals. The question is how to make propylene. What to do to make propylene? And the answer is by using the most common manufacturing technique, propane dehydrogenation, or what we call cracking of propane to make propylene. Let's see the example. Promise me you won't freak out when you see the question, because most of the chemical engineering problems, material balance analysis, will be something like this. It's a story, it's not a question, but bear with me. The catalytic dehydration of propane is carried out in a continuous packed bed reactor. So the type here is continuous. That's the first word we focus on. 1000 kilogram per hour. You need to label every key word in a sentence or in a question, because it's hardly to go back again to the question and read it. It will cause you to lose a lot of time. Pure propane is preheated to a temperature of 670. Preheated because we will heat it before it enters another process to a temperature of 670 degrees Celsius. It's a very, very hot temperature before it passes into the reactor. We will heat it and then we will introduce it to the reactor. The reactor effluent gas. Effluent is another word for product. The reactor product gas, the reactor effluent gas, the one that is leaving the reactor, which includes propane, the one we started with, propylene, the very important chemical that produces the three things we have discussed before, methane and hydrogen. All of them is in a product stream. And this product stream is cooled from 800 degrees Celsius to 110 degrees Celsius and fed. It means it goes into another process, and in this case it's called the absorption tower, where propane and propylene are dissolved in oil. So if it passes into an absorption tower, the propane and propylene will be captured, will be dissolved inside an oil. This oil that contains propane and propylene will go after the absorption tower to a stripping tower. And what happens inside the stripping tower? It will be heated and it will release the dissolved gas, and these gases are recompressed, which means their pressure increased, and then sent to a distillation column to separate propane from propylene. This propane now, the one that you separated from propylene, will be recycled, will be again introduced to the process, because we want to consume all of the propane to maximize the production rate of propylene, and propylene is really wanted to us. Recycled to join the reactor preheater. This product stream from the distillation column will contain 98% propylene. So one stream of distillation will contain 98% propylene, high purity, and the other stream will contain 97% of propane. You see the 97% of propane, it's the one that will go back again to the process. The stripped oil, the one that has been separated from propane and propylene inside the stripping column, will be recycled to the absorption tower to capture all of the propane that will enter again. Which propane? The propane that is recycled back to join the feed. It's 100% normal if you don't get anything that I said so far, because all of the things that I said is just words. And for a complicated process like this, it's very hard to understand a process with just simple words, and even simple clear words will not do. That's why we introduced this very, very important concept, which is called flowchart. I cannot emphasize further on flowchart. It's very important for you as a chemical engineer, mechanical engineer, to draw simple blocking system that transforms it into a simple drawing that will make you use less time and more efficiency to solve the problem, the very complicated story problem like this. I am sure you're gonna understand this easily now with flowchart. The process starts with pure propane with mass flow rate equal to 1000 kilogram per hour. A preheater enters that will heat pure propane to 670 degrees Celsius, right? Before it passes into the reactor. And then it will go to a reactor. The reactor effluent will have propane, methane, propylene, and hydrogen. These four chemicals are produced and they go together as one stream, which is called effluent stream. To cooler, it will be cooled off from 800 to T equal to 110 degrees Celsius. This tells you that still the effluent stream will be the same as this one here, because it's just heating process. It's not a reactor like this one. There is no generation consumption. Then four of them will go to an absorption tower where propane and propylene are dissolved in oil. These four chemicals, two of them will be dissolved in oil, which means that we will have a new stream in the absorption tower, feedstock or feed, which is oil. How can there be no oil if he said or she said that we have an oil that will take propylene and propane? It means we have an oil that will come to the absorption tower that will capture the propane and propylene. The stream that enters here will leave with methane and hydrogen only. The oil will leave, it said, will go to a stripping tower. Draw another stream, a stripping tower, and now this stripping tower will release the dissolved gases, which means propane and propylene will be separated inside the stripping tower, and the oil will leave alone. It will not leave with propane and propylene, it will leave alone. So this is the oil, and this is propane and propylene are separated. And then it said that they are recompressed, so we will still have propane and propylene, but their pressure increased. This propane and propylene will go to a distillation tower or distillation column, and then we will have propylene, and in the top we will have propane. That is the end of the process. This is in order to have propylene component alone. That's what we want. That's our objective. We want propane dehydrogenation into propylene. The propane stream is recycled back. Which propane stream? This one, propane stream, is recycled back to join the feed to reactor heater. We'll go all the way here. As the question said, it said also the stripped oil is recycled to the absorption tower. So this is the stripped oil. Oil entering a stripping tower, and then it will leave as a stripped oil. This stripped oil will go recycled to the absorption tower. So this will go here, recycled, and will be used, and recycled, will be used all the way to absorb or to use all of the oil in order to capture propylene and propane, and in order to separate them later on, and in order to recycle propane until they are consumed, until propane and oil are consumed. And by the time they are consumed, we will have the maximum production date of propylene. That's why we recycle. That's why we introduce the concept of recycling. With this drawing, I hope you will find it easy because you used what we call flowchart. Flowchart completely transforms this complicated question into a simple blocking system that will describe your process to a chemical engineer, to a mechanical engineer. Once they see the drawing, they will understand what you want to say, and they will understand what you are going to do with the process without even mentioning any word to them. That's the cool thing about the flowchart. And I don't know if you noticed it before or not, but I have been always talking about flowchart in the previous video. I always bring flowchart whenever I solve any problem and whenever I explain any concept. Say we are doing a flowchart. The next thing we are required to do is to label each and every stream. Each stream will have a certain information, and we need to put the known variables that are given to us in the question. Like this one, mass flow rate is equal to 1000 kilogram per hour. What was given also? 670 degrees Celsius, 800, 110. And then in the distillation column, propane has a 97% purity, while propylene has 98% purity. This purity, it wasn't specified whether or not it is weight or mole, but I'm assuming it is here weight fraction because the mass flow rate in the beginning of the question. This type of flow rate that we have been given in the question is called basis. Basis is a word you will hear and you will use a lot whenever you solve any question related to material balance, because sometimes you will not be given this flow rate. You will not know when to start, and so you need to create a certain basis that you start your calculation from, and then when you find every variable, they then will be relative to the basis. In this case, we are given the mass flow rate, so we will assume that this is X, because X is mass fraction of propane, and here is X for propylene. What else do we need to specify? The temperature that enters in the beginning of the process, the temperature of pure propane. It wasn't specified, and usually when the temperature is not specified at any problem, you have to assume that the temperature is at the room temperature. If it is not given in the question, you will assume it is 25, it will be 20, or specifically it will be room temperature. And room temperature is between 20 and 25 degrees Celsius. And it makes sense because it said here pure propane will come to a heater, so it will be heated. It means that the process is still in the beginning. We didn't do anything, so it is more likely to have propane at room temperature. And I tell you, most of the problems we as engineers have to assume. We have to assume, and we have to assume all the time, but the assumption we make must be logical. You cannot say pure propane at 25 is liquid. This is impossible. Pure propane, it will be gas, and it is most likely to be at 25 degrees Celsius because it is easier to have this temperature. It is the temperature of the room. The mass fraction here will be 1. The mass fraction of methane, hydrogen and propylene will all be 0 because it's pure propane. That's all the labeling we need to do, at least for now. Because you see this problem, it summarizes what you will take in your undergraduate courses as a chemical engineer. Heater, you will conduct energy balance. Reactor, you will conduct mole balance. Cooler, you will conduct energy balance. Absorption, mass or mole balance. For the stripped tower, also mass balance. Compressor, energy balance. And distillation, mass balance. So the course we will take will be related to how to conduct energy balance and material balance. And the first journey will start with material balance, and it will be a long journey. This is just how we will deal with the problems when we graduate. When we get to our workplace, we will do this kind of problems. So I'm glad I showed you the 0 step. So far we learned that when we have a very complicated problem, you should do flowchart. Number 2, you should label all the streams that are connected to the block. And number 3, choose your base if not given. Which one is not given? Either if the mole is not given or if the mass flow rate is not given. If you are given the volumetric flow rate, for example, then change the volumetric flow rate into mass or molar flow rate. Because as I said, the base will be either mole or mass. And if you are given volumetric flow rate, convert it to mass using density, and convert, if you want to convert to mole, because all the problem contains mole fraction, for example, then you need to convert using the molecular weight from mass to mole. Then you must ask yourself, is the problem solvable, or am I just wasting my time? And to know that, we need to conduct what we call degrees of freedom analysis. It tells you, do you have a solution to this problem you are solving or not? How can we know that this very complicated plant is solvable or not? We need to conduct degrees of freedom analysis here, all the way in each block to make sure that we have a solution. Each one of them must be done in order to solve a very complicated question in a simple way and with less amount of time. Flowchart gives you a map about the process, and it shortens your time instead of reading all the time the problem. Labeling all the streams will let you know what you have and what you missed in order to calculate. Choosing your base will tell you where you are. If you choose your base, then you know that the calculations are done based on that base. And usually when you select a certain base, then it has to be with the stream that contains the composition. For example, if you have a certain process and then here you have 0.55 maybe XA equal to 0.55, XB equal to 1 minus XA, for example, and then here you don't have anything. In both the streams you don't have the mass flow rate or the molar flow rate or even the volumetric flow rate, but here you have a composition, while here you don't have any composition. So if you choose a certain base like 100 gram, then you should put this 100 gram in the stream. You can find their flow rate, the component flow rate of A and B, and this will help you later on, as we will see, how to calculate the flow rate of A, the flow rate of B here, and the composition. So choosing a base is very important. It tells you how to calculate and solve the problem, and the selection of the base is very important. It has to be with the one that contains the mole or mass fraction. And then we need to conduct degree of freedom analysis to tell you, are we wasting our time or not? Does this problem have a solution or not? Later on I will solve a very long one using all of these 4 key factors, in addition to other things that I will add later on. Not like this. I just wanted to show the flowchart and the labeling of all the information. And as you know already, material balance is divided to 2 types. We have the reactive system and non-reactive system. We will start with this one, and then we will move on to the reactive system. And the non-reactive system includes the mixing, separator, like the distillation column. This was a type of separator, splitting point, and we will see what the future will hold.